Okay, Assalamualaikum and very good afternoon. So for the computer architecture and organization subject, we are from group 6 for the project. The title of the project is to calculate the volume of water tank level using Mary simulator. So in our group, we have 4 members. So firstly, my name is Muhammad Ashraf Jaria. Second.
Okay, my name is Muhammad Fakrul Shazwan bin Muhammad Fauzi.
The third one is me, Muhammad Iskandar bin Naziri, CE 180105.
And my name is Ahmad Haris bin Suhani. I'm the number CE 180054.
Okay, for the introduction. Volume of the tank is the calculation using right rectangular prism concept. The formula is V equal to length multiplied with width multiplied with height is a tank volume. We calculate the volume of 1000 cm is equal to 1 liter of water. When the water level is increased, the volume of the water tank will be increased to 2 times where 2 liter of water will be equal to 2000 cm.
For my part, for the methodology, we use for Mary simulator. So Mary, also we call it machine architecture that's really intuitive and easy. That's the term of the Mary. Mary simulator is a machine that architecture that assembly language that serve for the education purpose. So Mary simulator that was published provide that a set of a simulator program for the machine in the writing Java writing. So the Java writing that's a JavaScript version implementation of a Mary. So Mary that has uh, two simulation environment, which is a normal Mary simulation environment, and the second one is a Mary the path data path environment. Normal Mary simulation that just we programs using the programming that's based on the user. Maybe the data path that's we the show up the process from the started until the ended based on the programming we from the normal mirror simulation. So for the next one is a flowchart diagram.
Okay, for flowchart diagram, as you can see, the flowchart begin with start point and move to input parallelogram that shows the value of store A, store B, and store C. Then it moves to the rectangle shape, which means that the process is happen in that section. The process shows lot A equal to store A multiplied with store B. After that, it moves to the output process. In output process, lot A equal to count 2. After output process, the value of count 2 is stored and lot C equal to count 2 as an input. Then it process lot sum 1 equal to count 2 multiplied with store C and get the output of lot sum 2. The final answer is in lot sum 2 section. Then we end the process.
Okay, for the result and discussion, as you can see, this is coding that we use in Mary simulator. Okay, for the discussion about this coding, from the coding in figure, the output section starting from line 1 until line 10, store A is representing the value of length, while the store B is representing the value of width, and the value of the height is represented by store C. So, the formula that we use for the calculation is volume of tank equal length multiplied by width and multiplied by height. The volume of tank that we get from the calculation is 1000 cubic centimeter equal to 1 liter. Next, starting line 12 until line 22, this part is the first process for multiplication for the value of length equal to 20 centimeter and the value of width is equal to 5 centimeter. The result for the multiplication between the length and the width will be stored at the line 34 and will be used for the next multiplication with the value of height equal to 10 centimeter. This calculating process for this next multiplication starting from line 27 until line 35. Finally, the value of the tank equal equal 1000 cubic centimeter will be displayed at the output section in the next figure. Okay, this is the figure for the output that we get, and the right one is the output for the Mary database environment. Next.
Okay, as the conclusion, we learned that Mary simulator or Mary sim is a computer architecture simulator based on the Mary architecture and design to teach beginning computer organization and architecture. It provides users with interactive tools and simulation to help them depend on their understanding of the operation. A simple computer. We be able to understand the basic program of Mary simulator and make it as a calculator to find the volume of the tank.
For the question and answer session, for the first question is about what are the unique feature of our child projects. For this project, we normally that people have to calculate in manually to find out the answer. So we need to easier for the user. We need this project for the easy for the user to calculation the volume of the water tank level. So it can make to easy for information, easy for that without any manual calculation. So question 2.
Okay, for the question 2, what does current trend of computer architecture is related with your project? As we know, in industry, a lot of industry using their computer to control any engineering robot or any engineering process. Like in our project, this is the imaginary of industrial oil and gas who keep their oil, gas, water in the volume tank as a storage. Thank you.
Okay, for question 3, the question asks, explain on how your project can support the sustainable development. Okay, for my opinion, Mary Simulator was written in the Java language so that the system would be portable to any platform or which Java virtual machine JVM is available. By running the program of Mary Simulator, not only we will see the program action, but we will get a taste of assembly language programming without learning any particular assembly language beyond the simple instruction. Okay, next.
Okay, for the question 4, explain the current trend of computer architecture for sustainable development. Okay, for the answer, over the same period of time, the rise in the use of computers have increased many folds. The combined effect of the energy needs to run this device and the electricity required to maintain the cooling infrastructure for this device have an impact on the environment. This is an era of serious concern and is growing people for research in the field of green computing, which is about using computer in an eco-friendly way. That's all.
Okay, for demonstration our projects, this is our JavaScript. We have a project we do. So we assemble for the first input that for the store A. Store is the first input is a length of the tank. We put it around about 20. And then we need type of the value must be in decimal number, also the output number. So the first one is a 20. The second one, store B, is about the weight of the tank. So we put it around about 5 meter. And then there's the last one is about 10 for the weight of the tank. So accept. For the first, we go to the loop one. Loop one, first they will be put the first input, which is 20, and then I said the programs will be 2 times for loop because of the input B is 5 times. So they will loop until 5 times to get the answer what we want for this first loop. So for 20 times 5 equal to around about 100. So the final for the first loop will become the 100. After that, he will go to the loop 1, you go to the output 100, and then we get lot to count, subtract 1, again to count, again to skip 1, and to go to the count 2 to store the answer what you want the first loop. Go to the second loop, you store the first loop of the answer for the 100, and then because of the second loop is about from first loop answer is a 100 times to the input of C. Input of C is a 10, so the loop of the loop 2, the process of a loop will become to 10 times. So mean 100 times a 2 will be get 300, and so on. No, I means that the loop of two that we loop around what 10 times. So the 10 times 100 for the answer for the loop one will be times to the input of C equal to what we want. So the process a loop until the 10th time we will get the 1000. So I fast for the our delay. And then we go to store, and then we go to subtract and store skip point and jump to the end. This is for the end process. Load the answer and then the output and hold. So this is the process of the programs from the memory simulator. After that, we go to view for data path for our programs. Start for assembler. We run it. Okay, the value we put for the length is a 20, and then this start for after that for white is a 5. The height of 10 is 10. So he start the simulation for the programmer from start for the loop 1, and then we go to the after that we get the answer, go to the loop 2, and then after they get the answer, we go to the output and hold. So it it's take time because of the delay around about 1k ms. So we hold it until they get the answer. This is the end of the hold. The end of the programs we hold it for IR is a 7000, out for 13E8. They are the three. They are the number must be in the Hesa number. For IR the 7000, out it is 03EX, and in for 00A. AC is a 03EX E8. For MBR for 7000, PC is 021, and MAR is 0220. So that's all. That's all for our presentation. Thank you.